Law of conservation of mass, and writing balanced equations. The law of conservation of mass states that mass cannot be created or destroyed. This means that in a chemical reaction, the total mass of the reactants is always equal to the total mass of the products. In this experiment, you can see that eggshells, which are made up of calcium carbonate, are reacting with white vinegar, also known as acetic acid. The total mass of the starting materials is 140.9 grams. I then added the eggshells to the vinegar in a Ziploc bag, where the chemical reaction can happen in an airtight environment. We can see that a chemical reaction is happening as bubbles of gases are formed in the mixture. The product of this chemical reaction will be calcium acetate, water, and carbon dioxide. Even though the atoms from the reactants are rearranged, forming new substances, we can see that the total mass of the product is also 140.9 grams, same as the reactants, proving the law of conservation of mass. Now we know that the total mass of the reactants is always equal to the total mass of the products. We have to make sure that the chemical equations is balanced when we write it.
What does a balanced chemical equation look like? Well, it will have the same number of each type of atoms on both sides of the arrow.
Let's start with an equation. Here we have potassium chlorate decomposes into potassium chloride and oxygen gas. Let's start by creating a chart to count the atoms and record all the atoms on each side of the equation. In this reaction, we have 3 elements involved: potassium, chlorine, and oxygen. On the reactant side, there's 1 potassium, 1 chlorine, and 3 oxygen. On the product side, there's 1 potassium, 1 chlorine, and 2 oxygen. Always start by balancing the metals, then the nonmetals, and leave oxygen and hydrogen until the end. Since only oxygen is imbalanced right now, we will start by balancing oxygen. We can only add coefficients that are whole numbers to balance the equation, so we have to make the oxygen in the reactant side become an even number by adding a coefficient of 2. Every time you add a coefficient, you must recount all the atoms before adding other coefficients. We now have 6 oxygen on the reactant side, 2 chlorine, and 2 potassium. We can add a coefficient of 3 in front of the oxygen gas, so we now have 6 oxygen on the product side. However, now the potassium and chlorine is not balanced. To balance it, we can add a coefficient of 2 in front of potassium chloride. Now we have 2 potassium on the product side and 2 chlorine. And this is a balanced equation. Now we will be balancing a hexane combustion reaction. You can pause this video and try solving it on your own, or follow along to see how I balanced it. Again, we will start by creating a chart to count and record all the atoms on each side of the equation. At this point, your chart should look like this. Since we should always leave hydrogen and oxygen to the last, let's start with carbon by adding a coefficient of 6 to carbon dioxide. After recounting, we now have 6 carbon and 13 oxygen atoms on the product side. Then we can move on to hydrogen by adding a coefficient of 7 to water, making both carbon and hydrogen atoms balanced. It leaves us with 19 oxygen atoms. What do we do with the oxygen? It's an odd number. Since we can't add a coefficient with decimals to O2, we now have to double all coefficient of all reactants and products, except for O2. Then we should recount all atoms. The carbon and hydrogen should still be balanced, but we will now have 38 oxygen atoms. By adding a coefficient of 19 to O2, the equation will now be balanced. Recap: you can never change the subscripts of the compounds and elements. You can only add and change coefficients. Always start by balancing the metals, then non-metals, leaving oxygen and hydrogen to the last. Hope this video helps. The end.